National Electrical Code Section 210.21b2 addresses the use of flexible cords and cables in place of fixed wiring. The requirement states that flexible cords and cables shall not be used as a substitute for the fixed wiring of a structure. This code section is quite clear in its prohibition. It specifically prevents the use of flexible cords and cables, such as those found on cord plugs, as a replacement for fixed wiring. Fixed wiring, in this context, refers to wiring that is permanently installed within a building. This type of wiring is not intended for frequent movement or disconnection. It forms a permanent part of the building's electrical system. The rationale behind this code provision is to ensure the safety and reliability of electrical installations. Fixed wiring provides a secure and stable connection. It is designed to handle the electrical loads and environmental conditions present in a building. Flexible cords, while convenient for connecting portable equipment, are not designed for permanent installation. They are more susceptible to damage, wear, and accidental disconnection. Using flexible cords as a substitute for fixed wiring can create several hazards. Firstly, the cords may not be properly sized to handle the electrical load, leading to overheating and potentially fires. Secondly, the cords may be damaged by physical stress such as being pinched, stretched, or walked upon. This damage can expose live wires, creating a risk of electric shock. Thirdly, the cords may be easily disconnected, interrupting power to critical equipment or creating a tripping hazard. In the specific scenario of installing cord plugs on the ends of circuit wiring under equipment bases to plug in power strips, this practice is not permitted under Section 210.21b2. The code requires that the wiring be hardwired into a receptacle that is permanently installed in a fixed location. This ensures a secure and reliable electrical connection for the power strips and the equipment they serve. Hard wiring involves directly connecting the circuit wiring to the terminals of the receptacle using appropriate wiring methods and connectors. This creates a permanent electrical connection that is not easily disconnected. The receptacle itself should be securely mounted to a wall, floor, or other structural element to prevent it from being moved or damaged. There are some exceptions to the general rule against using flexible cords as fixed wiring, but these exceptions are limited to specific situations where the use of flexible cords is deemed necessary and safe. For example, flexible cords may be used to connect portable equipment or appliances that are designed to be moved from one location to another. However, even in these cases, the flexible cords must be properly sized, protected, and used in accordance with the manufacturer's instructions and all applicable electrical codes. To further understand the implications of this code section, it is helpful to consider the definitions of some key terms. Fixed wiring, as previously mentioned, refers to wiring that is permanently installed in a building and not subject to frequent movement or disconnection. Flexible cords and cables, on the other hand, are defined as cords and cables that are designed to be flexible and easily moved. Receptacles are defined as electrical outlets that provide a point of connection for portable equipment or appliances. Hard wiring refers to the process of directly connecting electrical wires to terminals or other components using appropriate wiring methods and connectors. It is important to note that the National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installations. It is developed and maintained by the National Fire Protection Association, a non-profit organization that is dedicated to reducing fire and other hazards. The NEC is widely adopted by states and municipalities throughout the United States and serves as the basis for many local electrical codes. Compliance with the NEC is essential to ensure the safety and reliability of electrical installations. Failure to comply with the code can result in fines, penalties, and even legal action. It can also create dangerous conditions that could lead to fires, electric shocks, and other hazards. If you have any questions or concerns about the proper application of the National Electrical Code, it is always best to consult with a qualified electrician or electrical inspector. These professionals have the knowledge and experience to ensure that your electrical installations are safe, code compliant, and properly functioning. In addition to Section 210.21b2, there are other sections of the National Electrical Code that may be relevant to the installation of power strips and other electrical equipment. For example, Section 110.3b requires that all electrical equipment be installed and used in accordance with the manufacturer's instructions. This means that you should always read and follow the instructions that come with your power strips and other electrical equipment. Section 300.11 addresses the support of electrical wiring and equipment. This section requires that all electrical wiring and equipment be securely supported to prevent them from being damaged or dislodged. Section 400 covers the use of flexible cords and cables. This section specifies the types of flexible cords and cables that are permitted for various applications and provides requirements for their installation and use. Section 406.4 covers the installation of receptacles. This section specifies the types of receptacles that are permitted for various locations and provides requirements for their installation and wiring. Section 408 covers the installation of panel boards. Panel boards are electrical distribution devices that contain circuit breakers or fuses. These devices are used to protect electrical circuits from overloads and short circuits. When installing power strips, it is important to consider the electrical load that they will be carrying. Power strips are typically rated for a maximum current of 15 amps. If you overload a power strip, it can overheat and potentially cause a fire. To avoid overloading a power strip, be sure to check the total current draw of all the devices that are plugged into it. The current draw of each device is typically listed on its nameplate. If the total current draw exceeds the power strip's rating, you should either use a different power strip with a higher rating or reduce the number of devices that are plugged into it. It is also important to use power strips that are listed by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. Listed power strips have been tested and certified to meet safety standards. Using unlisted power strips can be dangerous, as they may not be properly designed or manufactured. In addition to the electrical code requirements, there may also be local building codes or regulations that apply to electrical installations. Be sure to check with your local building department to determine what codes and regulations are in effect in your area. By following the National Electrical Code and all applicable local codes and regulations, you can ensure that your electrical installations are safe, code compliant, and properly functioning. Remember, electrical work can be dangerous. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. This ensures that the work is done safely and correctly. National Electrical Code Article 100 provides definitions for various terms used throughout the code. These definitions are essential for understanding the intent and application of the code requirements. It is recommended to review Article 100 to familiarize yourself with the definitions of key terms such as fixed wiring, flexible cords, receptacles, and tarred wiring. Chapter 2 of the National Electrical Code covers wiring and protection. This chapter includes requirements for conductor sizing, overcurrent protection, grounding, and bonding. These requirements are essential for ensuring the safety and reliability of electrical systems. Chapter 3 of the National Electrical Code covers wiring methods and materials. This chapter specifies the types of wiring methods and materials that are permitted for various applications. It includes requirements for conduit, cable, and other wiring systems. Chapter 4 of the National Electrical Code covers equipment for general use. This chapter includes requirements for receptacles, switches, luminaires, and other electrical equipment. Chapter 5 of the National Electrical Code covers special occupancies. This chapter includes requirements for electrical installations in hazardous locations, healthcare facilities, and other special occupancies. Chapter 6 of the National Electrical Code covers special equipment. This chapter includes requirements for electrical installations for elevators, escalators, and other special equipment. Chapter 7 of the National Electrical Code covers special conditions. This chapter includes requirements for electrical installations in emergency systems, standby power systems, and other special conditions. Chapter 8 of the National Electrical Code covers communications systems. This chapter includes requirements for electrical installations for telephone, data, and other communications systems. Chapter 9 of the National Electrical Code contains tables and examples. This chapter provides tables of conductor ampacities, conduit fill, and other information that is useful for electrical calculations. It also includes examples of how to apply the code requirements. Annex of the National Electrical Code is an informational annex that provides additional information and guidance on various topics covered in the code. Annex B of the National Electrical Code is a table of conductor properties. Annex C of the National Electrical Code contains conduit and tubing fill calculations. Annex D of the National Electrical Code contains examples. Annex E of the National Electrical Code contains recommendations for good electrical practices. These recommendations are not mandatory, but they can help to improve the safety and reliability of electrical installations. The National Electrical Code is updated every 3 years. The latest edition of the code should always be consulted when designing and installing electrical systems. The NEC is a living document that is constantly evolving to reflect changes in technology and best practices. Staying up to date on the latest code requirements is essential for all electrical professionals. Understanding the NEC requirements is crucial for safe and compliant electrical installations. When in doubt, always consult with a qualified electrician or electrical inspector. They can provide expert guidance and ensure that your electrical work meets all applicable codes and regulations. Remember that electrical safety is paramount. Always take precautions to protect yourself from electric shock and other hazards. To energize circuits before working on them, use appropriate personal protective equipment and follow safe work practices. By following these guidelines, you can help to prevent electrical accidents and injuries. Furthermore, consider that while power strips offer convenience, they can also pose risks if not used correctly. Avoid daisy-chaining power strips, which involves plugging one power strip into another. This can overload the circuit and create a fire hazard. Do not use power strips in wet or damp locations, as this can create a risk of electric shock. Inspect power strips regularly for damage, such as frayed cords or cracked housings. Replace damaged power strips immediately. Use power strips with built-in surge protection to protect your electronic devices from power surges. Power surges can damage or destroy sensitive electronic equipment. When not in use, unplug power strips to save energy and reduce the risk of fire. The use of extension cords should also be approached with caution. Avoid using extension cords as a permanent wiring solution. If you need a permanent outlet in a location where there isn't one, have a qualified electrician install one. Choose extension cords that are rated for the amperage of the devices you will be plugging into them. Do not overload extension cords. Inspect extension cords regularly for damage and replace them if necessary. Do not run extension cords under rugs or carpets, as this can trap heat and create a fire hazard. Unplug extension cords when not in use. In addition to the code requirements and safety precautions, it's essential to maintain proper documentation of electrical installations. Keep records of all electrical work that is performed, including wiring diagrams, equipment specifications, and inspection reports. This documentation can be helpful for troubleshooting problems, making future modifications, and demonstrating compliance with code requirements. Regular electrical inspections are also crucial for identifying potential hazards and ensuring that electrical systems are functioning safely. Schedule periodic inspections by a qualified electrician to check for problems such as loose connections, damaged wiring, and overloaded circuits. Address any issues that are identified during the inspections promptly. Proper maintenance of electrical systems is essential for preventing failures and extending the lifespan of equipment. Keep electrical equipment clean and free of dust and debris. Lubricate moving parts as needed. Repair or replace damaged components promptly. By following these maintenance practices, you can help to ensure that your electrical systems operate safely and reliably for many years to come. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always exercise caution and follow safe work practices when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician to do the job.